All right, well, we got a lot of new content for you guys today, so I'm not going to wait too long. I'm going to go ahead and get started. Thanks for joining, and again, if you got here just a minute or two late, type your questions in the Q&A bar, and I'll get to them all at the end if I can't get to them during the presentation. I also want to start by just letting you all know that we are hiring right now. We're hiring for several positions, but the ones I'm most aware of are sales applications engineers and technical support. So if you are interested in you don't want to work in installations anymore, you want to break from that, certainly I love it here, and I would definitely recommend that you apply. So without further ado, I'm going to go ahead and jump in here. Today we're going to be talking about replacing lead acid batteries with Phi batteries. Just having a bit of trouble here. There we go. Cool. So here at SimpliPhi Power, our mission is to provide safe, clean, reliable, and affordable energy to people, communities, and enterprises globally. Now, to do this, it's necessary to accelerate the energy transition to renewables. It's also necessary to really provide customers with distributed assets, as we can see that our infrastructure is failing. Especially here in California, we're experiencing more and more PSPS events, public safety power shutoff events, as time goes on, and we've just been notified that they're going to be even more next year. Additionally, providing distributed assets directly to customers' homes helps us build a more resilient energy future and provide insane economic value while we're doing all that. We use only lithium iron phosphate chemistry. Has several safety benefits that we're going to go into detail on, as well as performance benefits. And for a form factor, we use cylindrical cells. So think AA battery. That's what a cylindrical cell is. Pouch cells are great. You're going to often find them in laptops and smaller sized batteries. However, they are a bit prone to swelling and even puncture. And prismatic cells are great as well, but they're a bit bulkier, not allowing you to fit quite as much in a tighter package. So we found that cylindrical cells offer not only the best performance, but also the longest lifespan and just the safest, best performing battery in general. Now, when we compare lithium iron phosphate to other lithium chemistries, there's no danger of thermal runaway or fire, no toxic elements. It's even landfill safe due to the lack of toxic elements, like lead, for example. And there's no abusive mining practices involved in the composition of the materials for the battery. No ventilation, cooling equipment, or safety monitoring equipment required, and it's able to withstand higher temperatures than all of these other lithium batteries that you see on the screen mentioned. Nickel, NMC is one option, LMO another. Of these, I really truly believe that LFP is much safer and just better performing in general. But today, we're not going to talk about other lithium batteries much. We're going to focus on lead acid batteries. So we're going to first start by understanding lead acid batteries. We're going to talk about their form factor and chemistry. We're going to talk about troubleshooting lead acid as well as just regular maintenance. And we're also going to talk about why, when, and even how to replace your existing lead acid battery bank. Then we're going to wrap it up by talking about designing your new replacement bank with Phi batteries, some installation techniques, and the advantages you're going to see when you have those batteries installed. And as always, going to leave a good amount of time for an FAQ at the end so I can get to all your questions. So let's jump into lead acid form factor and chemistry comparisons. So here we have a flooded lead acid battery on the left and a sealed on the right. The main difference you're going to see here is the electrolyte, right? So the electrolyte in the flooded battery is literally floating around That's why they call it flooded. It's not really secured in any way, and it does have removable caps that you can screw off and add water to the battery, which you will need to do regularly. Now, this is basically just composed of a lead dioxide plate and a lead plate and sulfuric acid and water. Those sulfuric acid and water make up the electrolyte, and that's essentially one cell right there. So a sealed battery is essentially the same thing, except that the sulfuric acid and water, the electrolyte, is absorbed in a glass or gel mat that separates the lead dioxide and lead plate. So the main difference, again, is just the electrolyte is not floating around. The sealed battery does have a pressure release valve, but you do not need to add water. That valve is really only going to open if there's some sort of safety concern. So let's talk about maintenance and troubleshooting of lead acid battery systems. Oh, I skipped a slide, excuse me. I have found that flooded batteries last a bit longer, but only if you're really well maintaining them. And they're going to require watering, specific gravity checks regularly, as well as EQ charges. Sealed batteries are not going to last quite as long, but often EQ is not recommended. I mean, you have the advantage here of not maintaining the battery, so it's a trade-off, not lasting as long but not needing maintenance. So on the right-hand side here in the bottom, we see this graph. Note that gel and AGM are the two sealed type of batteries, and they are the dark red and bright red lines here. So ultimately, they are not going to last quite as long as the top of the line flooded lead acid battery. These charts are both from Trojan. I'm going to be picking on Trojan a lot today, not because they make bad batteries, not because they're a bad company. I think they make excellent lead acid batteries, but because they have data widely available that I just couldn't find with other companies. So I'm going to be using Trojan's data today for all of my lead acid figures. So maintenance and troubleshooting of lead acid battery systems, as far as regular maintenance, you're going to need to water the battery. So here, I'll just go in order here. You're going to want to give your battery a full charge, then add water, then do a specific gravity check with the hydrometer on the right. If it's not in the right range of specific gravity, you'll likely need to perform a manual EQ charge. That can be quite a long charge while you're kind of checking the specific gravity with the hydrometer every so often. Now, you can just use a flashlight, look into the battery, and try to guess, how much water to pour in. You can also use an auto watering system. It has a cap that will tell you when it's full and just not allow any additional water, kind of like a gas pump. Additionally, ventilation is absolutely needed here to prevent hydrogen from concentrating and possibly exploding. So once hydrogen builds up, all it needs is a small spark to ignite. But as long as your lead acid battery bank is ventilated, nice, 12-volt Zephyr vent fan we see here, this is just a great option to ventilate your lead acid battery bank. As long as it's ventilated, you're not going to have a problem with the battery exploding. However, I have seen people not realize this is necessary and install lead acid batteries in a sealed container. You can't do that even if they're AGM and sealed. You cannot be installing them in a sealed container. You need to have ventilation. And additional maintenance. So some issues you may be seeing with your lead acid system. First off, you might see sulfation. This is going to appear as white dust on the terminal, as well as just within the battery, the kind of white gathers on the lead plates. And this is actually lead sulfate. So lead sulfate is going to form on the plates when there is undercharging. So if the lead acid battery remains at a partial state of charge for a long time and it doesn't receive a nice full charge often, it will sulfate. Now this is definitely going to impact your performance of your battery, and in the long run, a lot of sulfation can just completely destroy your battery. This can even cause your battery to physically expand. And small amounts of sulfation you can often remove with a very long EQ charge, a controlled EQ charge, but large amounts definitely cannot be removed. Overcharging, on the other hand, is going to cause off-gassing, so don't undercharge or overcharge your lead acid battery. Now, overcharging is often happens when you have hot weather and you have temperature compensation disabled. You will end up electrolyzing water with the excess energy that you're putting into the battery, and this is going to cause the battery to vent hydrogen sulfide. That's not only toxic, but again, also explosive if ignited. Here's another issue you could be seeing with your system, even lead acid or even otherwise. You may be seeing a low battery cutout event. If your inverter has shut off, that's one of your things you may be seeing. So if your inverter shut off, first, don't just go and throw those batteries out and replace them. Let's troubleshoot this first. So you've got the potential that a low battery cutout event happened. Make sure to check the voltage of the batteries, and if they need it, recharge them. Your inverter could have shut off because there was an overcurrent event. In this case, you'll likely have just a switch on the inverter that you can just cycle off and back on, and it will often solve that problem. You may have experienced an overvoltage or reverse voltage event if you hook the battery up in the wrong direction, or if there was just too much voltage on the battery from being overcharged. This could actually damage your inverter. Maybe it blows a fuse, hopefully not. Depends on the inverter. And if your inverter shuts off due to low battery cutout, you might be experiencing reduced capacity because of low temperatures. So let's imagine you're at freezing point at 32 degrees Fahrenheit. Right around here, you've got about 70% of your battery capacity remaining. So if you've hit low battery cutout, you're thinking you didn't use that much energy, check the temperature. That could be an issue. All right, apologies, just reading through the questions here. I'll get to those all at the end. Now, if you're seeing your lights dim or flicker on your system, again, don't just pull your batteries out and throw them away. Let's make sure we understand why this is happening first so we can truly fix the issue. If your lights are 12 volt or DC in general, 24 or 48 volt lighting, and they are flickering when you have a large load on, that is usually not a problem. So, for example, I have a camper van, and when I turn on my microwave, my 12 volt lighting does flicker. That's normal because the voltage of the battery drops slightly as you demand a ton of current from it. However, if your 120 volt lighting is flickering, you either have too small of a battery bank and it's unable to power that lighting properly, or your inverter is producing an incorrect voltage or frequency. So now that we've hopefully troubleshot some of the issues that you could be seeing with your lead-based battery system, let's talk about when you would need to replace your batteries, why, or even how to replace them. So when you want to replace your batteries is if they have severely reduced capacity. Reduced capacity could look like you reaching low battery cutout more frequently than before, but you weren't really increasing your energy usage. It could even look like a voltage dropping under a significant load. So if you turn on your microwave and your battery voltage drops 5-6 volts, that could be an issue right there. You can also check your capacity, and Trojan says that their capacity guarantee is essentially if the battery fails to deliver half of its published capacity during the first 2 years. And just for comparison, our warranty is 80% within 10 years. So you can check capacity in several ways. One of them, you can just use a constant load and a known amount of time. So constant load would be something like lighting or heating. Maybe you have a resistive heater like a dish heater and you want to put it on full blast. That would be a constant known load. However, if you're going to run something like your dishwasher, it's not going to give you a constant load and you're probably not going to know how much power it's even using, so that's not going to be a good thing to use. But let's say you've got a 1,000-watt light bulb, 1,000 watts worth of lighting, and you want to run it for 2 hours. That's kilowatt times 2 hours is 2 kilowatt hours. So that's a great way to check capacity right there. Now, of course, you got to account for the losses through the wire and the inverter inefficiencies, but those are, I'm going to round to maybe 10% for an average system. Additionally, you could use a shunt-based amp hour meter. So Victron BMV712, going to plug it again. They make a great one. It's a rather accurate amp hour meter. It's going to tell you how many amp hours have come in or out of your battery bank. And I know a lot of lead acid battery installers listening have a little tester that you connect it to the lead acid battery terminals and it tests the battery in like 5 seconds. That is not going to work here to check capacity because cold cranking amps is not the same as capacity. And don't use your lead acid battery testers on lithium batteries either, because lithium batteries aren't designed to be starting engines necessarily. I mean, in some cases they are, but really in general, cold cranking amps just is not a super useful metric for lithium batteries. Now, why would you replace your batteries if you're not seeing reduced capacity? Here are some examples. You might be increasing your peak power demand. So you could actually be drawing, let's say you have a small off-grid cabin and you used to either run the microwave or the blender, but never both at the same time. And now you want to run both at the same time. That would increase your peak power demand. Another thing you may need is more autonomy or just more capacity in general. Now, a lot of times we see this need arise during the winter season. People, with battery issues, often the issues present themselves after the winter because that lead acid battery bank maybe remained at a partial state of charge all winter. Didn't quite get enough sun to fully boost it to full, and it may have sulfated. So due to limited sunlight availability during the winter, the sun's at a lower altitude instead of the summer, it's at a higher angle, and often your panels catch more sun during the summer. You may even see trees shading your array, luckily not necessarily during the winter, but this could be a concern in general that would force you to add more storage to your system. You may also need to upgrade if you're adding an extra charging source. So a lot of people don't consider the charge and discharge current rating of a battery. They just consider capacity. But if you're adding to your PV array size or you're adding a wind turbine or hydro turbine, then you could end up surpassing the manufacturer's charge current limit for the battery. And in that case, you would need to increase the size of your battery bank or change it in general. And if you're not changing your system layout, you don't have additional needs, and your capacity is not reduced, your batteries are working fine, why would you ever pull out your lead acid batteries? Well, maybe you're concerned about your health and safety, and that's a very valid concern because regular maintenance of flooded lead acid batteries exposes you to sulfuric acid, which is not good. We're going to talk a little bit more about this during a later portion of this webinar, but ultimately you definitely don't want to be doing maintenance on flooded lead acid batteries without proper protection. I see a lot of people really nonchalant about this, just flinging around a hydrometer with sulfuric acid on it while they're wearing a t-shirt and no glasses, and they don't realize the damage that that can have on their skin and eyes. Additionally, as far as failure modes, the worst case scenario would be that a lead acid battery would cause an explosion in your home. So actually, lead acid batteries off gas even during normal operation. They produce hydrogen if they are flooded. And again, hydrogen is not toxic but explosive. However, if the batteries are being overcharged, and this goes for both flooded and AGM or other sealed batteries, they will produce hydrogen sulfide, hydrogen sulfate, which is not only toxic but also explosive, and it can again just ignite with a spark if it's not vented properly. So how do you protect yourself from sulfuric acid and other lead exposure during maintenance of lead acid batteries? First off, wear PPE, and this is going to involve everything you see in the upper right hand corner. So this gentleman is using a very thick apron and boots and gloves, as well as a face shield and goggles. He's also got on long sleeves, and you can't see it, but I'm sure he's wearing long pants. When you're decommissioning your lead acid batteries, you would definitely want to be wearing that PPE. And so as far as decommissioning goes, here in the US, it's easy to, bring your battery back either where you bought it or where you're buying your new battery. If that's not an option, you can probably take it to a recycling facility and even get paid. Essentially, when you buy a lead acid battery, you pay an extra few bucks for the battery, and then when you go and recycle it, they pay you that few bucks back. So we have a really robust recycling program here in the US for lead acid batteries. However, overseas that is just not the case, and it's really unfortunate because it ends up in lead acid batteries just getting tossed, and they're getting tossed in places like you see in the bottom right hand corner where somebody is constantly dealing with issues like lead poisoning in that underdeveloped nation. So lead poisoning is a major, major issue because it essentially leads to over $1 trillion annually in not only healthcare costs, but the estimated cost of a lowered IQ from childhood lead exposure. So I don't know if everyone realizes how toxic lead is, not just for the environment, but more importantly even is for people. It's extremely toxic for the communities that it's dumped in. And $1 trillion, just for comparison's sake, is over 4 times the cost of what we experienced in terms of natural disaster cost globally in 2019. So we're paying 4 times as much annually to combat lead poisoning, healthcare, and lowered IQ costs than we are to rebuild infrastructure after natural disasters. That's just insane. Now, another point to make when you're removing lead acid batteries is that they're quite large, and you're definitely going to need a dolly or a pallet jack of some sort if it's a big system. This is a consideration to be made, especially when you're off grid before you even install these batteries. How are you going to remove them? Because in some remote scenarios, this is just near impossible to get these batteries in and out of the site. Whew. Okay, so now we have talked about lead acid batteries as far as chemistry and form factor, and we've talked about when, why, and how to replace them. So now that you've got them gone, let's talk about how to design your new Phi battery bank. First off, the easiest way is you can use these calculators on our website. Now our lead acid replacement calculator, I'm going to do a quick tour. This is designed to size your Phi battery replacement of your lead acid system. So I'm just going to enter in an example of a lead acid system here. Let's say we've got 24 6-volt batteries. That way you can arrange it in 3 strings of 8 for 48 volts. And let's say they are 200 amp hours per battery. Additionally, I'm just going to estimate you're using them at 30% depth of discharge. So that leaves you with around just under 9 kilowatt hours of usable energy in that bank. And also that's going to decrease if you're pulling at high discharge rates. Lead acid batteries are going to be less efficient as well. Now for 5 batteries, 3 batteries is going to give you a larger capacity than you had before, as well as a higher discharge rate. So again, this is a great tool. We've also got a SimpliPhi calculator that's going to help you in general just size your system based on your loads. This is going to be helpful, especially if your existing bank was a bit too small. And I find it easy to size a lithium replacement for a lead acid battery bank because they always have a higher discharge rating. From what I've seen, this means you can basically just size to match the capacity that you had or exceed it and not worry, knowing that your lithium battery bank has a higher discharge rate than your lead acid battery bank had. So this is going to help you avoid the need to examine spec sheets for hours and just simply match the usable capacity. Additionally, there's no maintenance, no specific gravity checks or watering with lithium batteries. There's no ventilation or spacing requirements with our batteries, so you can mount them almost any way you want, just not upside down, not stacked directly on top of each other. This is basically just means that our batteries are going to be flexible enough to fit into whatever mounting or box that you had for your previous batteries. As far as equipment compatibility, before purchasing your system or after, make sure that the equipment you're going to connect it to is compatible. So our batteries need to absorb at 56 volts for the 48 volt version, 28 volts for the 24 volt version, or 14 volts for the 12 volt version. I want to make sure that's clear. So the absorb timer also should be set. That's going to be 6 minutes. However, I know some of the older controllers that are built for lead acid batteries, they only have an absorb time of 1 hour. So if that's the case for you, you can absorb at 54.4 volts and for 1 hour. It's not going to be as fast of a charge, but it will get the job done if that's all you got. And on the low end, this is the other essential setting, is low battery cutout. This should be able to be set at a minimum of 48 volts. We really recommend 50 for the longest lifespan, but 48 volts is still acceptable and often used on backup systems that aren't used daily. Now, another consideration to be made is often we recommend is disabling float on your inverter and enabling float on your charge controller. This is because float is just not necessary on a lithium battery, right? Once it charges full, it really holds on to that charge, whereas a lead acid battery, it self-discharges quite quickly. I believe it's 5 to 15% per month, depending on the humidity and temperature of that environment that they're stored in. Whereas a Phi battery discharges less than 1% per month, so you don't really have to keep it topped off with a float charge. It's just not necessary, but it's not going to hurt the battery. So if you've got PV already coming in, might as well go ahead and use it. One more consideration here is, does the charge controller or inverter manufacturer actually want it to be used with lithium batteries? If they don't, it's going to maybe draw a red flag for you. It certainly would for me. Now, most importantly, make sure you follow the C/2 sizing rule. So I'm going to talk about that here. As far as sizing your battery system, the battery kilowatt hour capacity needs to be double the inverter's continuous output rating. So for an example, let's say you have the Radian 8 kilowatt continuous inverter. In that case, you need 16 kilowatt hours of battery storage. Simple as that. 5 batteries is over 16 kilowatt hours of storage, so 5 batteries per Radian is perfect. The reason for that is our batteries can be charged and discharged fully at a rate of C/2, which means they can be charged and discharged in 2 hours. Now, if the Radian was pulling 8 kilowatts from a 16 kilowatt hour bank, it would take it exactly 2 hours to discharge the bank. So you're sizing your bank properly to avoid any damage and make sure it's going to have a nice long lifespan and a good return on investment. As far as purchasing your battery bank, if you have not found a distributor already, all of our distributors offer design help, and they'd be happy to connect you to an installer as well. So if you need help finding a distributor or an installer, just check out our Where to Buy map. This is the first place we would send you. And if you have any additional questions, just feel free to contact our sales team via email or phone here at the bottom of the screen. And we'd be happy to connect you with a distributor or route you towards an installer. So now let's talk about the fun part, installing your Phi batteries. I love that we have a simple, understandable wiring method that we require. So ultimately, each positive terminal needs to be routed directly to a positive common bus bar, and the same with all the negative terminals to a negative common bus bar, or connection point in general. It doesn't need to be a bus bar necessarily. Now, using the same size, same length cable for each connection here is essential. This is going to promote balancing of the battery, make sure each of the batteries are at the same state of charge. Additionally, you can use combiners as this connection point here. This is what Andrew of Greenwire, one of our IQ installers, has done here. He's used I believe this is a midnight combiner, kind of hard to tell, but looks like it. And he's coiled the extra lengths of wire for the batteries that are closer in order to make them all the same length, same size cable. Another method you can use is to use terminal bus bars. So these big fat bus bars are super conductive, very low impedance from one end to the other, means it's going to be great to lay just directly on top of the terminals of the batteries, and then you can connect, your inverter charge controller wires directly to there. This was actually an 80 battery system at an airport hangar in Hawaii. Pretty cool project. Another option for combiners is to use power distribution panels. Now these are available with almost every inverter that you buy. They will offer you a PDP or a mini PDP maybe. Both going to be great, can serve as your connection point for your batteries. And make sure to use 6 gauge minimum wire size, but often we really see 2 gauge used most often. Now it depends on the length of the run, what wire size you actually need, but I usually just recommend 2 gauge from each battery to the connection point to be safe. Now last but not least, I want to stress that a torque wrench is definitely needed for installing our batteries. A socket wrench can often lead to over tightening and maybe stripping the terminals, or I've even seen lately people snap off a terminal completely because they just tightened it too tight with a socket wrench. They weren't knowing knowing what the torque was. Maybe they even have their torque wrench in a metric setting, I'm not sure, but make sure to use 160 inch-pounds to tighten the nuts on the terminals too. And if you have any questions about your installation, just give us a shout. Email and phone number are at the bottom of the screen right now. Tech support at simpliphipower.com. So here's what not to do with your Phi batteries. Do not wire terminal to terminal. As you see here, this is common practice for lead acid batteries. However, it does result in imbalances in lithium batteries. So really, each of these batteries should have a direct connection to a common connection point instead of daisy chaining as you see here. Don't wire them in series, of course, that is definitely going to cause damage. You cannot be using two 24-volt batteries in series to create a 48-volt battery bank, at least not with Phi batteries. Again, don't use a socket wrench and don't use small cables. Now, you can actually use TTHN, there's no problem with it. However, I've just found it difficult to work with. It's not super flexible, when you're maneuvering it around into a connection point inside of a small battery box or combiner. And it's a little bit harder to crimp a large lug onto those, but it's electrically fine. I just prefer the flexible battery cables. Now, commissioning. Once you've got all that wiring done, make sure to keep the breaker off during the wiring and then follow this order of commissioning. So once you've verified that all the voltages are within a volt of each other and everything is wired in parallel, none of them are wired reverse polarity, then go ahead and connect them to the bus bars to turn the breaker on each battery. Then you want to go, that's going to connect you to, let's say it's connecting you to the charge controller. Then you want to connect the charge controller to the power source like the PV panels. So turn that PV disconnect to the on position and allow the batteries to charge fully before powering loads. Loads are going to be connected last. So you can basically just keep your loads breaker in the off position during the install, and then once you're finished charging the batteries, you can turn the loads breaker on. If you don't have a charge controller, you can of course just connect the batteries to the inverter, charge from the grid, and then turn the loads breaker on once they're fully charged. So we have a few more people just joined us. And don't forget to put your questions in the Q&A. We're going to get to those pretty soon here. So a comparison between lead acid and Phi. And again, I'm just using Trojan because they have the most available data. A Trojan battery is rated to 2,000 cycles at 40% DOD. That chart is actually on the first slide as well, where you can see the number of cycles it's rated to at different depths of discharge. This is going to mean it's rated to a throughput of 800 times its rated capacity, just by multiplying 2,000 cycles times 40% depth of discharge. Now, a Phi battery is rated to 10,000 cycles at 80% depth of discharge. Multiplying those, you get 8,000 times rated capacity. So ultimately, 10 times longer lifespan in terms of throughput. Now, this is really going to help with your return on investment, as we're going to dive into in a few minutes here. And still, ancillary costs will add a lot of money to your cost of installation. And with a longer lasting battery that needs no maintenance, you're going to have way less cost over time. But we'll talk about that further. As far as efficiency, you're going to get a higher efficiency even at a higher discharge and charge rate out of the Phi battery. You're going to get 98% round trip. Lead acid varies greatly, but I'd say maybe 85% at a higher discharge rate would be expected. There's no maintenance required for Phi batteries, no watering, no specific gravity checks or EQ charges, no sulfation to deal with, and no off-gassing. They don't need ventilation. Higher energy density means that one person can carry a big amount of energy storage into a job site on their own. So no, it's a lightweight package. It's easy for one person to carry this 78-pound battery. Additionally, it has a stable capacity at all ends of the temperature range. So you're not going to see any significant capacity loss even at -4 degrees Fahrenheit. On the side of lead acid, we mentioned that you're getting 70% of your rated capacity at freezing. Also, health and safety benefits, no toxic components with Phi batteries, meaning there's no lead, no heavy metals. Performance advantages, a higher charge and discharge rate of C/2, and a big surge of 80 amps for 10 minutes. That goes for both our 48 volt and 24 volt batteries. The 24 and 48 volt 3.8 kilowatt hour batteries specifically is what that 80 amp surge rating is for. Not only is there going to be no maintenance, but no concern as far as self-discharge. The self-discharge rate is so minimal, it's less than 1% per month compared to lead acid's 5 to 15. Also, when installing a lithium battery bank, you have access to up to 100% of that capacity if you need it. We recommend 80% daily depth of discharge for the longest lifespan, but you're welcome to use 100 if you need it. Whereas with lead acid, 50% is the most that I see, and most people choose even lower, like 30 to 40% depth of discharge daily. Also, LFP are not going to be damaged by being in a partial state of charge for a long time. So if winter rolls around and you just don't have enough sunlight to top off your lithium iron phosphate Phi battery, it's not going to be damaged by being at 50% state of charge for weeks on end. Now, as far as cost advantages, we did talk about the longer lifespan and more throughput out of the Phi battery. When you note that our battery has a 10-year lifespan and lead acid batteries often last as short as 2 years, really helps you understand why ancillary costs play a big role in your return on investment, right? So if you have to pay somebody to haul your batteries in with a forklift or a crane or something crazy, then also pay them for maintenance over time, that's going to really add to the cost per kilowatt hour of the system. So let's just compare costs real quickly using our calculator here on the website. This is just I'll just do the most straightforward one. 3.8 kilowatt hour battery. I recently saw a quote for $25.99 and use it at 80% depth of discharge. That's about 8.5 cents per kilowatt hour. Now let's compare that to lead acid. This is a battery that I actually used to have in my camper. It was $320 on sale for 12 volt 200 amp hour battery, and I was using it at 50% DoD, so I was paying over 35 cents per kilowatt hour. And upfront cost, obviously some people end up paying more per kilowatt hour because they want to pay less upfront, and that's just how it goes, unfortunately. But in the long run, Phi batteries are going to be a much better return on investment. Now, additionally, we've already talked about many of the safety benefits of switching your lead acid batteries to Phi, but just noting that there's no risk of fire propagation and no maintenance which would expose you to toxic components. To reassure you that our batteries are extremely safe, we have put them through so much testing. Third-party testing I'm talking about here, not just our internal testing. This is UN 38.3 tests. So this is the test that essentially allows you to, or allows us to ship our batteries on airplanes. Now they've first passed the altitude test, being stored at low pressures, then thermal cycling, super high and super low temperatures for a long time, just rapidly cycling, hot and cold, hot and cold. They've passed intense vibration simulations as well as shocks, so just being dropped, thrown at the ground. This is going to simulate a crash or an impact. And additionally, they've passed short circuit tests and overcharging tests. Now, I'm not recommending you do any of these at home, absolutely not, and not even necessarily saying that they would be covered by warranty. Most likely not. However, it's just reassuring to know that your battery is not going to do something crazy like explode or off gas when a natural disaster happens or whatever happens that abuses your battery. Just knowing that it can take it and not cause a catastrophe is a nice relieving feeling. Now, in addition to the UN 38.3 tests, we've also completed the UL certifications necessary. So again, a very similar list of abusive tests that have been performed on the battery cells and trying to basically force them into thermal runaway and see how they react. And then going a step further, now even certifying the whole system as safe. So making sure that the battery is compatible with the other devices within the system. Now, last but not least, I want to touch on our SimpliPhi IQ program before we jump into the Q&A. Now, our IQ program is a great added benefit for distributors and installers. This is going to help you get increased sales for your SimpliPhi projects by highlighting your installer projects and showing that you have more knowledge of our products. Also going to provide you as an installer with much more exposure through our networks, such as our IQ newsletter. And I can tell you from experience, these installers featured in our newsletters are getting a lot of traffic from this newsletter. So that's definitely an exciting development, something that Troy and myself have been working pretty hard on, as well as our awesome marketing team here. Just making sure that you installers are getting the exposure that you guys deserve. And we're also going to be adding you to our IQ where to buy map. So essentially anyone searching for purchasing batteries or an installer for the batteries, this is where we're sending them. So with this spot on here, it's going to make you visible. If you're already installing our batteries, it's a no-brainer. It takes about 5 minutes to apply. And again, if you're already installing our batteries, we'd love to add you to our where to buy map and send some business your way and feature you on our media. It's awesome to have more and more photos to use for these presentations, and I'd love it if you guys would send them in, whether or not you're IQ certified, but especially for our IQ installers, I'd love to feature you guys in here. Last but not least, also wanted to just remind you guys that we are hiring, so check out our website if you need a job right now. If you're tired of being in the field installing, just let us know. Oh, all right. So let us jump through the Q&A, and make sure to get your questions in now so I can get to them today, guys. Are you sending a recorded training? Yep. If you signed up for this training, you will get a copy, a YouTube link to the training in your email. We've got greetings from Poland. Thank you, John, for the greetings from Poland. Good to hear from you. What time is it over there in Poland? Please, I need the slides of the presentation. Don't worry, you're all going to get the slides in your email. You're all going to get a copy of the YouTube recording. Is there something that can be put on to lead acid battery terminals to prevent or slow corrosion? Yeah, there is actually corrosion jelly. It's kind of like a Vaseline that you put over the terminals that can slow corrosion, but nothing's going to prevent corrosion because it's a natural process that just happens over time. In a hot climate, 65 to 110 degrees year-round, what's the effect of temperature on batteries and what charging parameters might be adjusted? So in cold temperatures for lead-acid batteries, you're going to need to temperature compensate by increasing the charge voltage. And in warm temperatures, you're going to need to reduce the charge voltage with temperature compensation. So if you're asking about the effect on lead acid batteries, you're going to lose a lot of capacity in the cold temperatures and actually gain a slight bit in the hot temperatures. As far as Phi batteries, they really aren't going to care about that temperature fluctuation, and there's no temperature compensation that should be used at all. It should be disabled. And you're not going to see any capacity decrease, really nothing significant, at least in cold temperatures. They will be totally operational within that temperature range there. Does using a load tester, even a cheap one from an auto parts store, provide a better test than a simple voltage check? No, the cheap load testers from auto parts stores are not going to do anything here. They're possibly even going to damage your battery if it's a lithium battery. You want to make sure to just do a load test, so actually run, like I said, a known load for a known amount of time and watch the voltage during that period. Tell me more about the battery enclosure on the wall over your left shoulder. So this is our Boss 12 cabinet. This is generally, it's just able to fit 12 batteries. It's got 4 racks and 3 batteries fit on each rack. And it comes with a big terminal post, one positive, one negative. When you combine that with bus bar kits, it makes it very nice to quick and easy install for 12 batteries, indoors or outdoors. It's actually outdoor rated. This guy can sit outside. It's NEMA 3R. And yeah, we do provide, but we do sell bus bar kits separately as well. Is it an AC or DC battery system for grid backup? As far as the Boss cabinet, it's just holding batteries, so you can put anything in there. It doesn't matter if it's an AC or DC coupled system. What about orientation of lead acid versus Phi batteries? Do they need to be stored upright? So lead acid, if it's a flooded lead acid, definitely needs to be stored upright. No other options there. Otherwise, they will leak electrolyte like you mentioned. As far as Phi batteries, they can be mounted straight up and down, laying down on their face, or left or right. Basically anything except being totally upside down, and you don't really want to stack them on top of each other because the terminals don't want to take that kind of weight over time. The AGM batteries, since they have the electrolyte absorbed in the mat in the separator between the two lead plates, those can sometimes be mounted on their side or face. It just depends on the manufacturer's, what they say. Approximate time for delivery from ordering, that's going to depend on who you order it from. Our batteries are readily available. We have a distribution network, as I showed on the where to buy page, so they often have stock of batteries that can ship out right away. So if they're near you, I've seen batteries arrive in just a couple of days on the fast end. Thank you. This was very interesting. Thanks. Great to have you, Nancy. Appreciate it. I strive for nothing more than to entertain you all. Kevin Frost said, I'm in Arizona. Yeah, there are definitely distributors there. that have batteries in stock. I believe that Northern Arizona Wind and Sun actually has batteries in stock right now. Thank you, Matt. Thank you for coming. What's the link to all YouTube webinars? If you just go to YouTube and type in SimpliPhi Power, that's going to pull up all of our videos and our channel, and you can find it that way, but we'll also send you a link after this. See, I've got just a few minutes left here. So any questions that you want to throw in here before I leave, please do that ASAP. Can you talk about your system behind you? This here is just a boss cabinet. So it's just full of batteries. This is actually a green screen. I'm very flattered that you did not notice, but I do have a battery system in my camper van that is actually two 12-volt Phi batteries, and that powers my 12-volt lighting. I have a Victron battery protect, making sure that the 12-volt DC loads don't draw the batteries down too far. What is a good use for lead acid batteries? Great question, because I don't mean to seem like I'm hating on lead batteries. They are great for some things. For example, starting your car. An AGM battery is awesome for using in your vehicle. I just wouldn't necessarily want them in my house, as I see them as somewhat toxic. Some people use them for camper vans because they, a lot of these DIY camper van builders are just on a super low budget, and they're not seeing the return on investment. They're not looking at the cost per kilowatt hour. They're just saying, I have $300. What can I buy? So that's often where I see lead acid, AGM batteries used. Lead acid batteries, I'd say, are also useful for scenarios where the battery is just going to be abused. If you have a customer that does stupid stuff with their battery bank all the time, like hooking it up to a wall plug or 120 volts, or they just do dumb stuff, then give them a lead acid battery, because it can handle a bit more abuse sometimes, depending on the battery. What results have you seen with Phi batteries being stored in sub-zero temperatures? So our batteries cannot be charged below freezing, but they can discharge all the way down to -4 degrees Fahrenheit. So the performance as far as discharging is not hindered at all by cold weather. However, you just don't want to charge the battery below freezing. And I see no reason that cold temperatures would, reduce the lifespan of your battery significantly, so long as you're not charging in those sub-freezing temperatures. Okay, so Thomas, I see you're looking for a battery replacement, for a lead acid replacement for your RV, and you're looking for 5 batteries. So this seems like something where you could use our 12-volt batteries. We do have our 1.4 kilowatt hour batteries. It's a bit smaller, and it comes with a bare wire sticking out of it already, making it a little easier to kind of drop in as a lead acid replacement. So this sounds like it would work fine on your 2000 watt inverter system. You would need, I want to say, maybe 5 to 6 batteries. It depends. You should check out our lead acid calculator that I toured. You mentioned shipping 5 batteries on a plane. What does it take to convince airlines and shippers that it is safe? You need to pass UN 38.3 testing. So it's very intense, and you guys don't have to worry about that. We do. This cabinet behind me holds 12 batteries, and it's NEMA 3R rated, so it can sit outside. Can you expand on why you cannot wire in series on lithium-ion batteries? You cannot wire our batteries in series 48 volts means 48 volts, right? So if you were to wire these in series, we talked about this during our BMS training, if one battery open circuit and it was a 96 volt system, then that one point where the circuit is opened is going to be exposed to all 96 volts. And if it's not designed to handle 96 volts, then it could damage it. So ultimately, it is about where the circuit opens and what the battery is designed for. There are lithium-ion batteries designed for higher voltage, and we do have a high voltage solution. If that's what you need, get in touch with us. But that's really more of a commercial thing. I've not seen systems higher than 48 volts for residential purposes. Where's the lead acid converter? That's going to be on our tools page. So go to our website and click tools. May we use the SimpliPhi logo after certification? Yes, after you pass the IQ test and you become certified, it's no problem. You can use our logo on your marketing materials. That's another plus. Good point. All right, and this is probably the last one I can get to today, but what would be the next battery generation? We actually just came out with our SimpliPhi battery. This is very similar to our Phi battery, except it has a stronger BMS with communications. So it's able to really communicate with the communicating inverters. Right now, the Solarc is the communicating inverter, and we're working on expanding that list. But by communicating with the inverter, the SimpliPhi is going to essentially tell the inverter how to treat it. It's going to say, hey, I only want to be charged at 37.5 amps, or I only want to be discharged at 37.5 amps. So this builds in more safety and security in your system and keeps the battery lasting as long as possible because you know it's being treated well. Many of those settings are auto-populated when you connect the communications from the battery to the inverter, leaving you with less work to do as far as programming. So batteries will be AI batteries. No, they're not artificial intelligence. They just are able to communicate with the inverter. If you want more details on how that works, maybe shoot us an email and we can try to incorporate that into a future training. But that's all I can tackle today. Thanks everybody for joining. And again, shoot me an email at training@SimpliPhi Power if you have any questions. Thanks.